Hello and welcome back to Mr. Reed Math, where we're going to once again take some of the mystery in math and make it past tense. And now we've got two videos in the buffer about how to find the surface area and volume of prisms and of cylinders. And we're going to move right on to the next shape, and that's going to be pyramids. All right. So there's one thing, I think more than anything else, that I really want to stress to you about pyramids, and that has to do with the difference between the height of a pyramid and the slant height of a pyramid. And if you see this drawing that I've got over here, now this is a pyramid that's got a square base, all right? And most of the pyramids that come to mind, when you think about Egypt, well, that's what we're talking about. It doesn't have to have a square base. It could have a triangle base. It could have a pentagon base. It could have all these different bases, all right? But I'm just showing you one now that has a square base. And you can see these two values here that I gave you. One of them is 80 feet, and I just made these numbers up, but 80 feet and 90 feet. All right, and the 80 feet would be as if you came up to the top and you drilled down through, and this is the apex, by the way, of the pyramid. You start at the apex and you drilled straight down to the middle of that square. All right, and that would be the height of the pyramid. But that height is not going to help you find the area of these triangles that are on the side. To find the area of a triangle, you need the height of the triangle, not the height of the pyramid. And so we've got this other line that we call the slant height. Okay, the slant height is going to be longer than the actual height of the pyramid. That's normal. Okay, but hopefully this will make sense as we go into the difference between the surface area and the volume. Now, when we're doing the surface area, again, the surface area is the outside of the shape, right? It's how much wrapping paper I would need. If I was going to wrap the Pyramid of Giza, well, how much wrapping paper would I? That'd be a lot. And what you need is you need the area of the base, and you need the area of however many triangles there are. If it's a hexagon pyramid, you're going to have 6 triangles. If it was a triangle pyramid, well, then you're going to have 3 triangles around the outside. This is a square-based pyramid, so this is going to have 4 around. Okay, so we take the base plus the 4 triangles. And you might say, well, Mr. Reed, you wouldn't need the base because there's no way you'd be able to lift the Pyramid of Giza. You're right, but let's just pretend we could. Okay, we're going to get all of the surface area, including the base. All right, now this kind of shows you again, this is the height of the pyramid is that line right here that goes through the middle of the pyramid and comes into contact down there in the middle. But when we find the area of these triangles, we're going to use the slant height, which is the actual height of the triangle, which is going to be the 90 feet. Okay? All right, so let's move over to the next page, and let's find the surface area. All right, so the first thing you do, the whole process is you add the area of the base to the area of all the triangles added together, okay? And it's very similar to what we did with the cereal box and with the other shapes. You just find each component, find its area, add it to the other components. Okay, so the base, if it's 100 feet, then it's 100 times 100 because it's a square, right? And 100 times 100 is 10,000 feet squared. Cool, easy. All right, then each triangle, there's 4 of them in this case because it's a square base. So one triangle would be the base of 100 times the slant height of that triangle, which would be 90 feet. So 100 times 90 divided by 2 equals 4,500 feet squared for each of the 4 triangles. All right, now you take that number and you multiply it times 4, and you get 18,000 feet squared for all of the lateral sides. Okay, so now I take this 10,000 plus 18,000, and I get 28,000 feet squared. And that is how much, that'd be a lot of wrapping paper to wrap a pyramid of that size. Okay? But always remember, always remember, there's a distance. Now, I'm getting ready to show you why we need the height of the pyramid too. But for surface area, you need the slant height. Okay? All right. Now, let's move on to the volume of a pyramid. Here is where we need the height of the pyramid. Okay? So, how do we do this? Well, again, with volume, we're dealing with what would fit on the inside. How much water would it hold? How much sand would it hold? That's how much space is there inside the surface area. Okay, and the way you calculate the volume of a pyramid, well, think of it this way. If I wanted to come up with the volume of a cube that was 100 times 100, then what I would do is I would get that. Let's see if I can get this picture right. There we go. Okay, and I would multiply 100 times 100 to get the area of the base, and I would multiply it times the height, and if it was a cube, it'd be 100. Okay, and there you go. Now a pyramid is very similar in how you start it up. You calculate the area of the base, okay, and you're going to multiply it times the height, but now there's all this dead space in there that's not going to be part of that, so you have to modify that. All right, and so the way they figured it out is the area of the pyramid, you find the area of the base, or I'm sorry, the volume of the pyramid, you find the area of the base, you multiply it times the height, but then you have to divide by 3 or multiply by 1/3, same thing. All right, so that's the process. So the formula is the area of the base times the height times 1/3, okay? Or you could say 1/3 base area, I don't know how you abbreviate that, times the height. Okay? Okay, so we take the area of the base is 100 times 100. That gives us the 10,000 feet squared. Right? The height of the pyramid is 80 feet. So now we take the 10,000 feet squared, multiply it times 80 feet, and we get 800,000 feet squared. Then we'd multiply that times 1/3, and it doesn't matter if it's a square-based pyramid or if it's a hexagon-based pyramid. Any pyramid, you always multiply the base area times the height, and then multiply it times 1/3. And in this case, when we do this pyramid, I'm not crazy about that number, but 266,667 feet cubed. Okay? And that's how you find the volume of a pyramid. The surface area, you just calculate the area of each of the components and add them together. The volume, area of the base, times the height, times 1/3. All right? I'll come back with cones in just a little bit.